For people who suffered severe burns, there's hope. They can be treated with skin grafts using human skin that's been cultured in a lab. Patients who receive these grafts tend to develop less scarring and usually heal in a fraction of the time. Culturing of skin allows us to save many lives. To grow skin, epidermis cells have to be isolated and made to multiply. It all begins with the removal of a small skin sample. The 10 million cells in this piece are enough to make a culture. The skin soaks in a medium containing penicillin and gentamicin, antibiotics which protect it from bacterial infection. Now a piece of skin is cut and delicately sectioned on a petri dish with a scalpel. The fat is gently detached from the dermis since it will not be needed in the culturing. The skin is cut into thin strips because thermolysin, the enzyme that separates the dermis from the epidermis, acts more efficiently on the small surfaces. Then an enzyme destroys the links uniting the dermis and the epidermis cells. This procedure is carried out in this incubator over 3 hours at a temperature of 98.6 degrees, or body temperature. Once incubation is over, the petri dish is removed from the incubator. Only the epidermis cells, also called keratinocytes, are retained. The epidermis is detached from the dermis with great precision. Now the strips are placed in a trypsination unit. Trypsin, an enzyme, will destroy the links uniting the epidermis cells in order to isolate them. This operation signals the cells to multiply now that they're in a favorable medium. In order to increase the effectiveness of trypsin, the trypsination unit is placed on an agitator. The cells do not have to remain in extended contact with the trypsin. They're inhibited with a medium containing serum. Then the liquid containing the cells in suspension is drawn off. Now the liquid is centrifuged to obtain two fractions. The base fraction containing the desired cells is at the bottom of the tube, while the upper floating fraction containing the trypsin has to be removed. This upper fraction is drawn off with a vacuum system. In order to eliminate all traces of trypsin, the culture medium is added to the base fraction and the whole is put back into suspension. Now the cells from the small skin sample have to be counted before being centrifuged a second time. The cells are counted by hand using a microscope or with this apparatus. The exact number of cells obtained during the extraction via biopsy is determined, as well as the number of cells that will have to be seeded for maximum growth. The bottom portion of keratinocytes is divided in these flasks, containing a culture medium whose composition resembles that of blood. The cells will multiply over a week in these flasks, placed in an oven at 98.6 degrees and at 8% oxygen. The medium in which the cells are immersed is changed every 2 days. In less than a week, the cells have almost covered the entire surface of the flask. They can now be trypsinated anew, and thus reseed some 50 flasks, which in turn will be placed in the oven for about 1 week. Skin strips carpet the inner surface of the flask. They are then detached with a spatula. The flasks are cut in two with a heating unit resembling a soldering iron. To make handling easier, gauze is placed on the skin strips whose thickness is less than 1/10 of a millimeter. The graft is placed on the wound. Clamps and the gauze will be removed after 10 days. A patient can be skin grafted in less than 2 weeks.